Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the hypergeometric distribution. So it is another discrete probability distribution similar to the binomial distribution. So here we're still having all these Bernoulli trials one after the other. But the difference between hypergeometric and binomial is that in the binomial distribution, we have trials performed with replacement. Hypergeometric distribution trials are without replacement. So it's kind of the analogous form of the binomial distribution when things are done without replacement. So like the binomial distribution, we're still going to calculate the number of successes. So let's look at this example here. So bag contains 4 Mars bars, 3 crunchies, 1 boost. We pick 4 chocolates randomly without replacement. What's the probability of at least 3 Mars bars? So just as an aside, if I said the 4 chocolates are chosen with replacement, we would use the binomial distribution. But because they're without replacement, we use the hypergeometric distribution. So I'm going to let my random variable x be the number of Mars bars, or the number of successes. That's similar to the binomial distribution. So here, I want to calculate the probability that I get 3 Mars bars plus the probability I get 4 Mars bars. Because if I'm picking 4 chocolates, I can either get 3 Mars bars or 4 Mars bars to satisfy this here. So how am I going to calculate this here, the probability I get exactly 3 Mars bars? Well, the idea behind this is actually pretty simple. The number of ways the event can occur over the total number of outcomes. That's the most basic formula for calculating the probability of an event. So I'm going to figure out how many ways I can pick 3 Mars bars and how many ways I can pick the chocolates in total. So we'll start with the bottom because it's probably the easiest to understand. The number of ways I can pick the chocolate in total, there are 8 chocolates, and I'm going to choose 4 of them. That's what it was said in the questions. That's the total number of ways to pick the chocolates. So how many ways can I pick exactly 3 Mars bars? Well, there are 4 Mars bars, and I'm choosing 3 of them. But if I pick 3 Mars bars, I've picked one of the other 4 chocolates. So for each way I pick the Mars bar, I have to pick the other chocolate a different way. So there are 4 options for the other chocolate, and I'm picking one of them. So this is, of the 4 Mars bars, I'm picking 3, and of the 4 other chocolates, the crunchies and boosts, I'm picking 1. So putting that on our calculator, 4 choose 3 is 4, 4 choose 1 is 4, so it's 4 times 4, 16 over 70. So we can just put those C calculations on our calculator. All right, now we have to find the probability that I pick all 4 Mars bars. So it's the same idea. 8 choose 4, which is 70. There are 70 ways I can pick the chocolates in total. Now we have to figure out how many of them involve 4 Mars bars. Well, I'd be picking all 4 Mars bars, and of the other 4 chocolates, I'd be picking none. So 4 choose 4 and 4 choose 0 are just 1. There's only one way that I can pick all 4 Mars bars. So this will become 1 over 70. So the total probability is 17 over 70, just adding up these two numbers. And that gives us about 0.2429, about 0.243. So there's about a 24.3% chance that we will get at least 3 Mars bars. So let's look at the actual formula now. So this here is the formula for calculating hypergeometric probabilities. It looks a bit complicated and has 4 unknowns you need to put into the formula, but it really makes a lot of logical sense, as does the expected value. So let's highlight how to use this formula in this example. So 6-person basketball team is going to be randomly picked from 8 year 12 and 4 year 11 students. So how many year 11 students do we expect? So let's go through and calculate all of these. So firstly, big N is the population size, how many there are in total. So there are 8 year 12s and 4 year 11s. So there are 12 in total. K is the number of successes in the population. So here we're talking about year 11 students. So the year 11 student is a success. So what we're saying is the number of successes is the number of year 11s in the population, which is 4. So N is the number of trials. Here we're picking 6 people, so 6 is the number of trials. And K is the number of successes we want. Although K is not in the expected value formula, we're going to use it down here. So in this question, we want 2 year 11 students, so little k is going to be 2. So how many year 11 students do we expect? Well, it's just little n times k over big N. So it's 6 times 4 over 12, which is 2. Now this makes sense, right? Because 4 out of 12, or 1/3 of the total pool of students, was year 11. So we expect that 1/3 of the 6-person basketball team will be from year 11. So we expect 1/3 of 6, or 2 of them, to be from year 11. So what is the probability exactly 2 year 11 students are picked? Well, the formula says it's big K, choose little k, times, so big N minus k, 12 minus 4 is 8. And then on the bottom, little n minus little k, 6 minus 2 is 4. And that's all over big N, 12. Choose little n, which is 6. So what's this saying? Well, 12 choose 6 is the total number of ways you can pick 6 people from a group of 12. 8 year 12s, 4 year 11s, there are 12 students in total. This here is the number of different ways you can pick 2 year 11 students from a group of 4. And then this is saying, because there's 6 people on the basketball team, we need to pick 4 year 12 students from the group of 8. So for each one of these, each combination of year 11 students, there is this many combinations of year 12 students to make up the other 4. So that's what we're doing. So using our calculator, 4 choose 2, 4C2 gives us 6. 8 choose 4 is 70, and 12 choose 6 is 924. So putting that on our calculator, we get 0.45 recurring. That is the probability that we will get exactly 2 year 11 students. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.